All right, so the one little new thing that I wanted to go over, and it's not really new, it's kind of just an extension from what we did yesterday, all right? Again, on page 873, okay, sector area. So, yesterday, we took fractions of the circumference, right? So we found arc length. Let's see if I got it right here. So we took, like, for example, a circle, and we didn't want to find the full circumference. We just wanted to find the distance along that little piece. Well, now today, okay, we're going to take the area of the circle, but we're not going to find the area of the entire circle. We want to find the area of a wedge, okay? Now, wedge is not a mathematical term. We have sector, okay? That's what we call that. So that little wedge of our kind of pie here, okay, that's a sector, all right? And so basically, the way we're going to do this is very similar to what we did with the arc length yesterday. Okay, we're going to start by finding the area of the whole circle, the full thing here. So the area formula, by the way, tomorrow you won't have to have the area formula memorized. Either you'll have it in your notes or I'll put it up on the board or something like that, okay? But the area of a circle is pi times the radius squared. Okay, so in this case, for this circle, what is the radius of this circle? Yeah, it's 15 millimeters, so I'm just going to put 15 right in there. Okay, and then we're going to go ahead and just multiply this all together. So pi times 15 squared. So I get 706 point, I'm going to round that up to 0.9. 706.9 millimeters. And in this case, our units should be what? Squared. They should be millimeters squared. Millimeters, though, yes, but square millimeters. Okay, you're talking about area. Square millimeters. Okay? But of course, we're not interested in the full area. I only want the area of this sector. Okay? Anyone want to, like, make a conjecture here? What do you think we should do then to kind of get that only that piece? What should we do now with this number? It's similar to what we did yesterday with arc length. This is the full area. I only want the sector of this fraction, this part of it. Multiply 706.9 times what? Yeah, so 1/3, or let's I'll make it even like kind of more obvious here. It should be 120 out of 360, right? The 360 is the full kind of degree measure around the outside of around the circle. We only want this piece of it, so we're going to do 120 over 360. That's the fraction times 706.9. Okay, but Julio's right there. In this case, 120 over 360 does imply to 1/3. It is 1/3 of the area. So we're just going to do 1/3 of the area basically. All right, so we'll take that and do 120 divided by 360. Oh, sorry. 2 pi r is if we're doing arc length. That's for circumference. We're finding the area, so it's pi r squared is the circumference formula. Or the area formula. Okay, 235.6 is what we get then.
If it's pi r squared, then why aren't we doing that 120 divided by 60 times 6 pi r?
Well, so this was that was the pi r squared. We did pi r squared to get to the 706.9. So this is the area of the circle. This is the area of the sector. Little piece there, the wedge of the pie. Does that clear it up for you there? Okay. So that's it. Okay? And that's basically it. Okay, that's it. You just take the area formula, like we took the circumference formula, and you put the degree measure over 360 in front of it, and that then gives you the area of the sector. All right, so let's just kind of jump over here to try another one. All right, so on page 874, the very next page, you can see there's kind of your generic formula right there. The area of a sector with a central angle of m degrees of a circle with radius r is given by a equals m over 360 times pi r squared. So there's the formula right there for you. Okay. So you can see here for letter A, they already have it kind of set up for us, right? 210 degrees is the arc there. So they put the 210 over 360. Radius is 3, so times pi 3 squared, and just do that math, and you get about 16.49 inches squared. All right, so there it is. Pretty straightforward. Let's look at letter B. This one they didn't do for us here, but they set it up. Okay. So for letter B, all right. Let's see here. So Jaden, for letter B here, what's the m? What should we put over 360 in letter B here, Jaden? 131, exactly right. So we'll do 100, I'm going to do the work over here. I don't like using these boxes. They're just too much of a hassle. So 131 over 360 times, good, and then we pi r squared. So pi, and then what's our radius here, Jaden?
12.
Yep, you got it, 12 squared. Okay, and now we can just type that whole thing in our calculator. Okay, so put parentheses, 131 divided by 360 times pi times 12 squared. I get 164.6 approximately meters squared. Okay, so again, if we were to make that circle, physically make it, you know, with a 12-meter radius and mark off a 131-degree sector like that, the area of it would be 164.6 meters squared. Okay, pretty straightforward there. All right. Let's do one more together, and then I'll have you guys try one, and then that's it. Okay, and I'll get you guys the kind of review assignment we're going to be doing then. Okay, that's number 4. Questions on any of that so far? Okay, let's look at number 4 then. So again, I'll start off by writing out our formula here. We want to find the area of the sector. So we'll do m over 360 times pi times radius squared. All right, so let's see here. So, Alicia, in this case, what is our m? What's the measure of that arc that we're looking for, the measure of that sector? There's no degree measure given, is there? But what can we say? What I mean, it looks like it's half the circle, so that means it should be what then? 180, exactly right. Yeah, 180 out of 360 times pi times the radius squared. What's the radius in this case?
Oh, it's
What do you say it is, Alicia? Is it 1.6? Why not? That's the diameter, right. So if the diameter is 1.6, if the diameter goes from you can see how it's marked there, it's measuring from A to B, 1.6. So yeah, it's not 1.6, but what do we do to that number to get then the radius? Divided by 2, exactly right. So half of 1.6 is 0.8. So it'll be 0.8 squared. Okay, so be on your toes there, right? We got to make sure we're plugging in for the radius. So in the past 2 examples we did, they gave, or actually the past 3 examples that we did, all the numbers were exactly what they should be. Here we had to do a little bit of work, right? There is no degree measure given here. Alicia had to figure out it's 180, okay? The R was not given to us. It was the diameter, but Alicia had to figure out, okay, 1.6 divide that by 2, 0.8. So just be on your toes a little bit there, right? But we can catch that, no problem. So 180 divided by 360 times pi times 0.8 squared is about, wow, I'm just going to go ahead and say that's 1. Okay, 1.0, so I'll just say it's 1.
I've got 100.
Did you put a decimal with your 0.8?
Yeah.
You did? All right, so I would recheck what you typed in, because I typed it in correctly, I can see. So recheck what you typed in there. It should just be 1. So we'll say about 1.0 centimeters squared is our answer there.
Now I got 10.
Okay, I'll come take a look at what you're typing in. Go ahead, try number 5, folks. Try number 5. Try number 5. Yeah, absolutely. Try number 5. Okay, take 2 seconds there and try number 5. Let me just finish this one, Ikeba, and then I will be right back. Okay, so... Okay. You're gonna think. Serious? I know, that's a struggle.
I got it.
Okay, so you fixed it though.
I typed it in.
Let me see what you typed earlier.
Oh, I already.
I can go back and see. Oh, okay, so this one I can see you didn't do over 360, you did over 36. And then... Okay, and then the other one, yeah, you didn't put 0.8, it was 8 squared. Yes, what's your R though? Oh, right there's the right one. Yes, exactly. Yes. Oh wait, this this meets the, yeah, but it's not 180, it's the, what's your angle measure? 5, which should be up there. Yes, perfect, good job.
And you gotta type in your calculator correct.
And the formula is pi r squared, right?
For area, pi r squared, exactly right. And again, it's given to you, you know, on the earlier page there too.
Do you do like millimeter squared?
Yes, exactly, because we're talking about an area here, Zara, exactly right.
Area of a circle.
Sector area of a circle. Area of a circle, pi r squared, yes.
Yes, good. That's great. So you see it's degree, so that goes with the 360 because it's a degree measure there. So what is the radius? Right there. The radius, remember, the radius measures the center of the circle to a point on the circle. So here's the center of the circle, and measures to a point on the circle. So what's this length? Yeah, 24 millimeters. And it's squared. I'm right there here, let me get Jane. The N.
Did you ever say that?
Well, it says it's M over 360, where we put in, we put 180 over 360.
113.
Okay, here we took 131 over 360. Where did I get the 131 from? Right there.
You not multiply by 2.
The 180, right, it's not listed here, but you can see it's half the
So
circle.
that is
Half the circle is 180.
22.5 over 360.
Well, what's the angle there? Yeah, that's it. Yep, that's it. And what's the radius of that circle? 22.5 over 360. Times pi times the radius, squared, 24 squared.
You did turn 22.5 divided to that chart.
Yes.
Yeah.
Yes.
We call it
Do you want us to still round it or just divide it?
Yeah, you can do that, and then times pi, then times 24, then times 24 again.
Do you want?
I'll be right there, Mel, 1 second, sorry.
0 and
If it's like a straight line like that, yes. Yes, exactly. All right, sorry, Ramel, I'll be right there. I'm getting Zari on this. That's right. All right, Ramel, what'd you get, sir? Yes,
Where's mom right?
that's right, Ramel. Just watch, Ramel, watch your units, though. It should be millimeters squared, not centimeters. Yes, that's good. It should be millimeters, not centimeters.
Do you want us to round it or just?
Yes, do round it. The directions will direct you about how to round it and stuff. Okay. 1 second. Let me go over the answer here, and then I'll get your question. Okay. Let's go to someone who's here. All right, Josh, you got an answer for us here, sir? Number 5. You got an answer? Got stuck? Okay. Where'd you get stuck? What'd you have trouble with? Just setting it up? Okay. So I'll show you that in a second. I don't want to reveal it because it'll give away all the information.
Can I do it?
Yeah, go ahead, Zaria.
At 113.1.
Yes, it should be, yep, 113.1 millimeters squared. Okay, so Josh, you want to find the area of this wedge, this sector. Okay, the degree is 22.5 for that arc. So 22.5 is the degree, that goes over 360, the full circle is 360, right? Times pi, and then the radius here is 24, so 24 squared. That's it. Okay. Questions? EKBS.
Yeah, so, like, if you have a circle,
Yes.
and you don't have a measurement.
Of
but-
the arc, you mean, or something?
Right, but it has a right angle, like,
Yes.
box on it.
Then
and
you can
it's
say
not
90 degrees.
Okay.
All right, folks, so let me give you guys some review here.
Will you teach me how to do this?
Yes, I'll show you that once we get started on the review here. Krishna?
I gotta do this.
All right, I'll come back and take a look at it in a second. Okay. So, what I have here are two papers, front and back, okay? You do not have to do every single problem on this paper, okay? But what I would like for you to do, okay, is kind of like, basically like use the rest of the time in the class to go over these questions. Like I said, you don't have to do all of them, but you should, like, I would definitely take a good look at each side, try some problems from each section, okay? You know, make sure that you convince yourself. Like if you do, for example, if you look here and it says like the diameter of a circle is given, find the radius. If you do that first one, you're like, okay, I think I got this one, I'm going to move on, then feel free to do that, okay? Don't feel like you have to do all four of those, okay? Yes?
Can we do all of them
I'm not good, I don't know. I'll think about that. I know because then you'll be doing them though, so probably not. Maybe I'll give you like a one homework extra credit or something like that. Something like that. All right. So because I'm not going to count this for homework, so what if you want to, if you do it all, and then I'll give you like 2 points towards another homework or something like that. Okay. So this is not going to be homework, but I do want you to use the rest of class. Okay. You have about half an hour or so. Okay. Please use your time wisely. I really want to make sure that some of you guys, do well in this quiz tomorrow because it could hurt, help your grade, not hurt your grade. I want to help your grade. So please take this seriously, okay? I'll give you like a bonus. I'll just give you like a full credit for one of your homeworks if you like missed one or something like that.
So I think that's really
Yes. So Jane again, or Jordan, sorry. Don't feel like you have to go through all of those. Just like pick. Actually, they're both for you. So just just kind of go through it. If you only want to do like the evens or the odds or even not even that, just kind of go through and just pick some to do. I guess is what I'll say. I'll kind of leave it up to you. Look through them. If you feel like you can do it, then just do it. So remember, this is our next to last quiz tomorrow. We only have one more quiz after tomorrow, so we really want to make sure we do well on this one so we can. Yes, there should. He needs both of those. There's 2 pages.
Oh, sorry.
It will. Yes, I won't give you full credit for them. I'll give you like 3/4 credit, but it's still better than a 0, right? So, wait, what's going on here?
I don't know.
Oh, okay, I got you. Okay. Yeah. There's for you, Alicia. On the border line, make sure it goes on the upper side of that border, right? So, if you want to, make up some work for me and stuff like that, you can point it back. No, I understand, but if you get the other assignments done, I do.
Oh, Mr. Wade, I didn't do it.
Got it. Oh, and Kayla. All right. There you go, back row.
This would be right? Like if you have the diameter, you would do 6 times 5.
So if you have the diameter and you want to find the radius is just half of the diameter.
I just think how long these. I don't know if it's like.
Okay.
Is that name again?
Let's see here. I'm going to do it on the backboard here for Daria, so if you want to follow along with Daria, we're going to do it right now, okay? Question. 5
pi over 6.
No, like.
Oh, right, so your calculator there. Remember, you're converting it from radians to degrees. So you don't have to think like that. You have to set up. Yeah, you want to log into that computer right there, it should. Hang on.
Or if you want to grab a Chromebook out, I think you can look it up that way, right? You want to go out of the card?
Oh, gosh, all right. Okay, let's look it up in a little bit here, because I got to do this first. All right, I'm going to go over, they're on the back, they're handwritten, right there.
Got locked out of my house.
Let's talk about converting. Okay, well, that's half the battle right there. Okay. Okay, converting from degrees to radians. So, in that one there we have 30 degrees. Okay. So yeah, here we go. We have 30 degrees, so we're going to convert that to a radian measure. We don't know what that is.
Then again, I had to think.
We're going to set that equal to a degree in radian measure that we do know. We know that 180 degrees is pi radians.
Well, you can set it up that way.
Yeah, you can put 1/8 over pi equals 3 over 6.
That's not baking. I just think
It comes from this idea.
right?
Circumference formula is 2 pi radians, right? 2 times pi times radians. Right? But, and remember, circumference, that measures around the outside of the circle. Right? But what else is
Oh,
in the
okay.
outside? Well, 360 degrees. Also, so we can say that those two things are kind of equivalent. So 360 degrees equals, you ready for this?
You'd be like my dad.
Pi radians. We don't call radiuses, we call them radians. So that's what I kind of comes from. It's basically about putting the idea of circumference together with the degree. 2 pi radiuses equals 60. Okay? So Jake, what you could do here is instead of using 180, instead of using 180 over pi, Jason, you could use 360 over 2 pi. That works too, because that matters. But what I do is, just to simplify it some, I divide both sides by 2, and it ends up at 180 degrees, and it has equal pi radians. Okay, so divide by 2, divide by 2, and that. You could use, so, well, I'm just trying to show James where we got this from, how we know this is true. And it's the idea that 360 degrees goes on the outside of the circle, 2 pi radiuses goes on the outside of the circle, 2 for the circumference, and so I divide by 2 radius, 180 pi radius. So, yes. Yes, so we get 30 pi equals 180, and we don't multiply the pi through, we leave that pi out. We would divide, so we 30 over 180, we divide both sides by 180. And so x equals 30 pi over 180, and then you can simplify this fraction.
Yeah, I don't know how to do that.
To hit math enter to convert to a fraction. Okay, so do 30 pi 180. You're doing that one. Okay, so then do 40 divided by 180. Hit math enter. No, don't multiply through by don't put the pi there, just do 30 over 180. Yep, 2 pi. Yep, so 2 pi over 9.
I think so. Oh, that's why.
It's 2 pi over 9, that's the answer. You converted it to radius.
You know what I mean? You played 1,000. So it's 1 pi over 6.
So for you, yes, it'd be 1 pi over 6, or just pi over 6, 1 pi over 6. That's it. Okay, you're good? Garrett? Go ahead. 9 over 360? And then it's 1/4. It's 1/4.
Then you go to eat over
The area of the shaded sector? So, in this case, the shaded region is the entire circle, so you just find the area of the circle, so that's pi r squared.
Okay,
Right, yep. Area equals pi r squared. Okay, but then this, that's not the full circle, you just want this wedge. But, you still use this area formula for the circle, it's still pi r squared, but you put a fraction in front of it to then only get the fraction of the circle that you want. The fraction you put out front is 90, since the angle is 90, 90 over 360 times pi r squared. That's it. Alright, let me get, Jordan, I'll be right back there. If you're given the radius, how do you find the diameter? You just take the radius and multiply it by 2. To find the radius, so given the diameter, to find the radius, you divide by 2. To find the radius given, or sorry, to find the diameter given the radius, you multiply by 2. The radius is half the diameter. The diameter is twice the radius. That's all. Alright, Kate, what's up? And then.
Oh, so for things like this, like dimensions
Which one, sorry?
MQN.
MQN. Okay, so what I would do here is I would see that. Go
Wait,
ahead.
hold on, could you do 360 minus 60?
Yes, because these are verticals, and that'll be 63. So if you do MQN and you just do 360 minus that, yes, exactly right. Yep. Oh, I'm sorry. Let me get a little bit up here because I broke my one. Don't worry about those. You won't worry about those. Let me go through the words with you here, and you'll probably be able to figure it out. So common means that it's shared by both. It's in common with them, so it's shared, like when you have something in common with someone else, you would share a trait, so they are sharing it. External means it's outside the circle, and it's a tangent, so it means it touches the circle's only one point. So a common, shared, external, outside tangent, like DE. DE is an external tangent. It intersects each circle at one point. Okay? So that is a common internal tangent. It goes between the two circles. You see how it's on one side and the other side? So you don't need to worry about that. You can don't worry about 19, 20, 21. Those you don't need to worry about. Yes. Oh, I see. And the slash for the radius too. I got you. Okay. I thought you were dividing them by 2. I was like, I'm not sure what that means. Oh, sorry. I'm coming. And then Garrett, and then okay, Garrett. Thanks.
When I'm, do I always put it in a
90 over 3.
Do I always put it in a
And 90. Make sure you put a 90 here.
Are we gonna go over these?
Tomorrow, yes, before the quiz.
How do I get MR?
And will we be able to?
Yes.
I don't know how to get it.
So MR, okay, you figured out what MN was, right? It's 63. So NMR, this is 180, right? You got it. Exactly. You can do 180 minus 63. All right, Chris, don't worry about those. So yeah, those you don't need to worry about, and also this. What's that? It's a line that intersects the circle of All right, right there, 1 second.
With what problem did you say not spot at all? I don't want to do it.
Actually, right here, you can cross off FG there, and then also 19, 20, 21. And I think that should be it. Everything else you should be able to do. Alright. I'm coming. Yeah, because the line, you want to have a line for secant in these things.
Oh, I'm still recording, I need to stop.